Hey guys, welcome to video 8 of the Cilk Plus tutorial. Today we're going to be looking at Mergesort, uh, which is a really good example for multi-threaded programming because of Mergesort's parallel tendencies. Basically, because it's a divide and conquer algorithm, it would be very efficient to implement it on multiple cores. So if you are not familiar with Mergesort, you can take a look at Wikipedia, you could look up online. There's plenty of references to Mergesort all over the place. But let's go ahead and open up the code for Cilk. Okay, so all we're going to need is our Cilk header. We're going to include random, time, and math. We're gonna use math for some power of twos. We're gonna use time, obviously, to time our stuff. We're gonna use cilk.h to make everything go in parallel, and then we're gonna use random to initialize our starting arrays with random numbers. So down here in main, here's what we're doing. First, we're gonna make a max array size. So I figured 2 to the 27, or I think that's 134 million. So we're gonna be sorting 130 million values, and the maximum value of our array. Actually, we don't need that. Yeah, no, since we're doing arrays of unsigned shorts, we are going to be only going up to 65,000. So all of our values in our array can be between 0 and 65,000. So here's our initialization of the random number generator. We're going to start off at 2 to the 14, and I think that's like the 16,000. Not too sure. We'll double check when we run it. But anyways, basically we're going to do a run of Mergesort for 2 to the 14, and then we're going to do a run for 2 to the 15, 2 to the 16, 2 to the 17, 2 to the 18, until we get to our 2 to the 27. So we're going to try Mergesort on multiple different sizes for our arrays. So here we are initializing the array. Here's our array notation to vectorize our initialization. So we're going to assign all of our random values to the list, and we're going to go from 0 all the way to the size of the array. We're going to start the clock. We're going to do our merge sort. We're going to finish, print our results. This was just, if you want to uncomment this, I'm going to be posting this file later to the description, but you can uncomment this just to double check that the array is sorted, but you don't have to if you already ran it and you know it sorts them properly. And then so we're doing it serially first, and then we're going to assign new random values to the array again using our vectorized array notation. We're going to start the clock again, and this time we're going to do parallel merge sort. So we're going to do the merging in parallel and the clock, and then check and see if the parallel runtime is less than the serial runtime. And then again, you can uncomment if you want to verify that it sorted it properly. Then once we're done all that, we're going to delete the list to free the memory we just allocated up here. And we're going to increment our power of 2. So we're going to go all the way back up here. And then we're going to go ahead and go for the next size. We're going to run through all the different sizes from 2 to the 14, 2 to the 15, 2 to the 16, all the way up to 2 to the 27. And then we're going to finish. So let's do a build one more time. Oh yeah, and make sure that you have your optimization set on in Visual Studio. and go ahead and go Alt F5 and we'll look at the results. So as we can see, it starts off when we have smaller values. The parallel and serial merge sorts are around the same. There's, yeah, this guy. So once I got to this guy, you can see that the parallel merge sort had a little bit of an issue with the number of threads that it's scheduling. So there was a little bit of overhead here on scheduling, and that's why the serial merge sort was a little bit quicker than the parallel merge sort for this size. But as we can see, if we continue to go along, it's just getting more and more efficient to do the parallel merge sort rather than the serial merge sort. So look at this, for 2 to the 24 we've already got 5 times speed up. For this one it's still pretty much 5 times speed up. Over here, yeah, it's a little bit more than 5 times speed up here. This one's 6 times speed up, so as you can see, as the size gets higher, the parallel merge sort gets more and more and more efficient over the serial merge sort. And as you can see in my task manager here, all the threads were going at 100% when we were looking to merge the larger sized arrays. Now if we go up here into the code, so for the verify method we've got just it would have printed failed if any of the lists were incorrect. This is parallel merge sort, so merge. Okay, so here's our merge sort. So it's pretty much the standard merge sort that everyone's used to. You find a midpoint value. I did this little fancy thing to prevent overflow. I know most people go end plus start divided by 2, but I do this guy just in case. Merge sort the left half, merge sort the right half, and then merge the entire thing. That's pretty much merge sort. And then the merge function is pretty much a typical, there's a whole bunch of different ways to merge. You could use while loops, you could use for loops. I decided to keep things a little bit simple, use one for loop, use two left array, and a right array. I'm doing a little bit of array notation here to vectorize as much as I can. And then at the end of the merge, of course, we're going to free the memory that we allocated for the merge. The parallel merge, parallel merge sort is pretty much exactly the same as the serial merge sort, except for the first guy up here, we're doing cilk spawn. And then before we merge, we got a cilk sync to make sure that both of these halves are returned before we sync up and then merge the whole thing. So yeah, that basically covers it. There are techniques to do a parallel merge, but they are rather quite complicated. I'm going to provide a bunch of different links in the descriptions for you guys to go ahead and investigate further. There's Dr. Dobbs, who has a pretty complicated approach on doing it. There's papers by different people on how to do it in their own little way. Parallel merge sort right here. There's even PowerPoint presentations here where they do a lot of the explanations. What else do we got here? And there's this guy. Oh, well, this guy is a little bit more promising. It seems this guy seems to be a little bit more simple. So I'll provide a link for this guy in the description for you to look at. But basically, the parallel merge is this algorithm right here. You're going to want to change up your parameters up here because you're going to have to pass more parameters and maybe calculate a little bit more things before you call merge. But other than that, everything else is pretty much the same. Yeah, parallel merge sort. So here's the in our code it's just very, very simple. You just do Cilk spawn here and a Cilk sink there, right here. But for these guys, you're doing a little bit more stuff, and then you do the spawn in the sink. And then you're, of course, you're passing a few more things. So yeah, give this a look. Take a look at it. Another thing is that if you do use the parallel merge, there could be quite a lot of overhead because of the number of threads that you're creating. So Cilk Plus actually does a really good job of determining your grain sizes, or determining the maximum amount of threads that you can spawn at one time based on the number of processors you have and the amount of data that you're going through. So it actually does a really good job of taking care of that. But if you're adding another spawn and sync procedure, if you checked out my video tutorial number 3, I do go in a little bit of an explanation about how doing Cilk spawn and Cilk sync within a loop is much less efficient than just doing a Cilk for. So yeah, just keep that stuff in mind when you look into doing parallel merge sort. And yeah, that's about it.